In this lesson, we're going to be graphing linear inequalities. One of the things we want to review quick is when we graph inequalities, is even the word inequality. Sometimes that seems a little bit confusing to people. It's the word we use instead of equation. So when I have an equation, I use an equal sign. When I have an inequality, it would either use the greater than, less than, greater than or equal to, less than or equal to symbols. That's the only difference between that and an equation. One of the things you have to do when you're solving a linear inequality is that you switch the direction of the sign if you multiply or divide by a negative. You might remember doing that before. But if you multiply or divide by a negative, and divide by or multiply by means you're doing it to all of the terms in the equation, not just what's on top. It's not being divided. You're not dividing a number by a negative or with a negative. You're dividing by a negative. So that's the difference. So multiply or divide by a negative. And we'll see one of those right away, so you can check that. We shade above the line with these symbols. So we're going to fill this in and we'll talk about them as I teach the problems to you, but I want to have these in your notes. So if your equation is in slope-intercept form, we shade above the line with the greater than and greater than or equal to symbol, and we shade below the line with the less than or equal to symbol. Dotted or dashed lines are used for the greater than or less than symbol, just like we do open and closed circles. This would be an open circle or a dotted line because the points on that line are not included in our solution. And a solid line is used for a greater than or equal to, less than or equal to inequality. And that's like a closed circle, so those points are included in your solution. So you can copy that down and refer back to that if you need to while you're working on problems. Our first problem is to graph this. So we are going to graph this line. We could graph this using intercepts because it's in standard form, but I will show you how to graph it using slope-intercept form since that's what most students prefer. So first I would need to get the y by itself by minusing 2x from both sides. And then I'm going to divide everything by -3. Now this is what I mean by dividing by. I have the bottom number that's being divided is negative. So I'm going to have to switch that sign. So that sign is going to switch into a less than or equal to. And that's what you're going to have to remember. That's the kind of tricky part about it. So I'd have y is less than or equal to 2/3 x minus 2. So now I have my slope and my y-intercept, and now I just need to graph it. So I would start with my b, my y-intercept, at -2, and I would move with my slope. My slope is 2/3, so up to right 3 or down to left 3. I'm going to connect these dots, but I have to decide if it should be a solid or dashed line. Since my symbol is less than or equal to, that tells me it should be a solid line. And hopefully you use a straight edge for this. I'll just freehand it. And there's the equation of that line. Now this is the equation of the line. This is y equals 2/3 x minus 2. If I want it to be y is less than or equal to 2/3 x minus 2, I need to shade where y is going less than. So here's the y-axis. Here's where y is going greater than. Here's where y is going less than. Well, since my problem says less than, I shade on this side. So I'm going to go ahead and pick my shading. We'll do stars, how about? And I'm going to shade everywhere below that line. And what this is telling me is that any ordered pair I pick in the shaded area or on the line would satisfy the inequality, meaning it would make a true statement like 2 is less than 3 or 10 is less than or equal to 7. That's what that's telling me. So any point I can pick in that starred area or on the line would work for my inequality. The next one then is x is greater than y. First I like to have y by itself and have it in slope-intercept form. So I'm actually going to rewrite this and flip-flop it, but I also need to flip-flop my inequality if I choose to do that. And I might be a little confused on how to start to graph this one. A lot of students think that this is either a vertical or horizontal line. It's not because it has an x and a y. You just have to write in the slope and y-intercept. My slope would be a 1. And my y-intercept would be 0 because they have nothing there. So when I start to graph this line, I would start at 0 and I'd move up 1, right 1 because my slope is 1. So I'm going to go all the way through or down 1, left 1. It's a less than symbol, so I would do a dashed line because the points on the graph or on this line are not included in my solution. They don't satisfy the inequality. And again, it says y is less than. This is where y is going less than. So I'm going to shade where y is going less than, all down here. So I'm following that line and shading everywhere below. And you can use colored pencils for this, or just your pencil can shade it, it's fine. But every point in this area is what satisfies that inequality. Okay, and I think that should be a good enough review for you because you've already graphed inequalities. It's just the shading and the dash and solid you're going to have to get used to. So the last two we're going to do are kind of our special cases. Hopefully in number 3 you recognize that to be a vertical line. So instead of getting y by itself, I would get x by itself. So I have x is greater than or equal to -2. That would be a solid line. X is greater than or equal to -2. So I'm going to draw a solid line on here at -2 on the x-axis. So that's right here. Make little arrows on this. And then this time when I decide where I'm shading, I have to actually follow the x-axis because it says x is greater than or equal to -2. So x is less than going this way, and x is greater than going that way. So to do greater than or equal to, I would actually go to the right. So I'm going to say everything this way is shaded. There is your answer. So that shader is your answer. The last one we're going to do, hopefully you recognize as a horizontal line because we only have a y. You can solve this a couple ways. I would maybe move the y over here because that's how a lot of students like to see it. So y plus 3 is greater than 4. You minus 3 from both sides, we get y is greater than 1. Since it's greater than and not greater than or equal to, I would draw my horizontal line is a dash line. So I'm going to do a dash line at 1. And then to decide where I'm shading, it says y is greater than 1. So I'm going upwards there. So I'd shade above my line in this case. So anywhere up here. And those are all of my solutions. And that's it. There's your 4 example problems.